TEK 3F is in the linear category. It's about graphing systems of equations. The TEK says that students are expected to graph systems of two linear equations in two variables on the coordinate plane and determine the solutions if they exist. So what a question might look like for this is letting students determine the three types of solutions that we might have. 99% of the time, we're going to see a system that looks like this, where the two equations meet at an intersection point where it has one solution, and that solution is the coordinate x comma y where they cross. Now the second option is that the students notice that the lines never intersect. They are what are called parallel, which we've talked about before. And parallel lines do not intersect. They will never intersect. So they have no solution. They have no intersection point. The third option is this last one, which you might look at and say there's only one line. Well, here's what happens. There's actually another line graphed right underneath that one where the lines are right on top of each other. So we have the students use arm motions for this. They either have one solution, no solution, or infinitely many solutions where the lines are right on top of each other, to show the three types of solutions we can have, which is part of this TEK. Now, what we need to do is actually be able to do this. So we're going to solve this system of linear equations by graphing. Now, we've talked about graphing before, so I'm going to kind of blow by how to do this. You can go back to find the graphing video in chapter 3. But we're going to begin the first one at 5, because that's its y-intercept, and its slope is -2, which means I go down 2 points and to the right 1, down 2 to the right 1, until I feel confident that I can draw a good straight line through it. I'm going to grab my ruler. I'm going to draw a straight line through all of those points. And I totally graphed that wrong. Ignore that one. Okay, so there's my line. Ignoring that one. The second line is going to begin at -1, since its y-intercept is -1, and its slope is 4, which means we go up 4 and to the right 1. 1, 2, 3, 4 to the right 1. 2, 3, 4. It's kind of off the grid. I'll draw a straight line anyways. And there we have our graphed system of equations. Now, comparing it to the graphic we had before, 1, none, or infinitely many solutions, this has one solution. Now, we want to solve it, which means we don't just want to say there's one solution. We want to actually be able to say that the solution exists at 1, 3, which is the coordinate where that intersection point exists. This is the solution to a system of equations. Now, what a star question might look like is something like this. It says, which graph can be used to find the solution to the system of equations below? Now, we are given two equations that one is written in standard form and one is written in not quite any form. Now, we graph equations in slope-intercept form, so we're going to change, I'm going to zoom in actually. Pardon. Sorry, I'm going to zoom in. I'm going to zoom in here and I'm going to solve that equation for y. So what that means is I'm going to take this equation and I'm going to move the 2x to the other side so that now it's a -2x. And that equation is solved for y. Second equation, to get y by itself, I'm going to divide each piece by -3. If you don't know what I'm doing, this is TEK 12e that you can go look at if you need help. And this equation becomes y equal to -2/3 x minus 4. Okay. Ooh, okay, now they're in forms that I can graph. So I can look at these options here and I can see which one of these represents the same thing. So we need the black line, the one that I wrote in black, to cross at -4. Good. And have a slope of -2. Does this one go down 2 and over 1? Down 1, 2, over 1. No, it does not. So we're going to eliminate answer choice H because it doesn't work for the black line. This one doesn't even cross at -4, so it's definitely not right. And this one crosses at -4. It has a slope of -2. Seems pretty good. So we have a couple, just two that have survived the first one. Now we look at the second one. Again, we need it to cross at -4. The other line does cross at -4 here and has a slope of -2/3, so it goes down 2 and over 3. That looks pretty good. This one does not cross at 4, which means that our answer choice is letter F. It's the only one that is graphed those two lines that we solved for y and plotted. Now, if this had asked us for the solution, we'd be able to say that the solution is 0, -4, because that's the coordinate where that solution exists. But we're just trying to match up the graphs. Now, one question might ask something like this. It says the line graphed on the grid represents first of two equations in a system of linear equations. They did half the work for us. If the graph of the second equation of the system passes through the point -12, 20, so let's plot that, -12, 20, and 4, 12, 12, which statement is true? All right, well, we know that that's a line, so I'm going to do my best to draw an absolute straight line between them. And something should be plainly obvious to us here. Of the three options, one solution, no solution, infinitely many solution, this looks like no solution. It does not, we're going to hold on to this one, letter choice C. It does not land right on top of each other, so it's not infinitely many. And if we were to plot these other two, 10, 5, it'd be like right here, or 0, 14 would be about here. Neither of those are where the lines are crossing, so B and A don't make any sense. So we're guaranteed that this system has no solution, because they do not cross. As always, we empower, we impact, we love. We are Skeeter Nation.